And off we go. Oh, see, the only thing I don't like is that it drops this toolbar in where I don't want it. Down here. And go over here. Okay, so did we figure out what was wrong with our get first?
Yeah, the int node.
What do you mean the int node?
You need to change int node to int.
Okay, so raise your hand if you figured out what was wrong with this thing. Only 2 of you?
It's actually fine.
What?
Easy the next thing.
To fix the get first?
Yeah.
Okay, yeah, hopefully it was, right? Because when we think about what we're trying to do here, if we have a series of nodes back here, you know what I'm going to have us do? We'll do it in a minute. Or we can do it right now. If we have a, oh, hi, Mr. Spider. Okay, if we are trying to get first, what do we actually want? Like if we think about what is this thing, what's the whole thing? Okay, but what is the structure? It's an int node, right? Yes? What's this thing? An int node. So when I get first, what is that currently giving me? An int node. Is that what I want? If I gave you a list, and I said, get the first thing, what do you want to give me? 4. So in that case, do we want an int node?
No.
Or a number.
You want a number. What's a number? What is the number in here?
1 int.
It's an int. So the first thing I know is that I need to change that, as Gordon said. I'm not returning an int node. Because what does an int node give me? If I returned an int node, what is it actually giving me? A whole structure. I don't want that. I want an int. So what's first? If I return first here, what is first? It's an int node. Is that what I want? Nope, don't want that. So I want first, I want the number inside first. So Ethan, what'd you do? First dot next. Okay. Well, that's an int node too. Dot next. If I come up here and look inside of my int node structure, I can say, oh, next is an int node. First dot item.
Oh, yeah, I did that.
Oh, I made my item.
Don't do that. Don't. No, and I'm saying that, and I say that jokingly, but you really want to make sure that the int is the item is an int because that's the thing inside,
Yep.
and your next is an int node. Because remember, next is always pointing at. Next is always just the pointer at the next int node.
Yeah.
Cool. Okay, that is our fix for. What did we just fix? Get first. Right? Add first should work. Now, what are we going to do to test these things right now? Did you guys test these things?
No.
Nope. So we need a main method. So we're going to comment out this particular thing here. I'm going to teach you a trick. If you just type main and hit enter, it gives you the main method. Lowercase m. Right? And then what do we need to do to actually test this thing? How are we going to test this thing?
Call the method.
Call which method?
Get first.
Get first.
Would you like it to do
They need
next doc get first?
to
Do static.
create a new int node first.
Oh, Oh, yeah.
I'm not making anything static.
But then you create an instance.
Create an instance of what, Tony?
I mean, like
Don't want to create an int node, right? SLList, yeah. Because if we think, remember, we want int node to be abstracted away. We want to not ever touch int nodes. But we do have to create a new SList. So SList list equals new SList. And now here, do we have to put in a parameter for right now? Well, I can abstract away my whole int node class. And does my current constructor require me to pass in an item?
Yes.
Yep. Let's go ahead. I'm going to put in 2. Oops, 2. Whatever. You can put in whatever value you want. And then let's go ahead and add a few more things here. How would we add a couple of more items to make this a slightly longer list? Oops. Add first. I don't know. I'm gonna do Fibonacci just because why not? List.add first 5. We'll just do 3 values. List.add first 8. Okay. What else are you going to use? You can't. Exactly. You got it. Well done. I can't use anything else because this is ground up structure. You can only use the methods we built, which is kind of fun. Now, why is it still giving me a problem with get first? List.get first. I have to either make it static or I have to call it on the specific instance. Here I want to make it on the specific instance. When I get now, is it going to do anything when I just run the program? I can either print it, or the nice thing about the debugger is that I can actually step through and, oops, I got to, so it's, when I get this no execution trace, remember we have to drop in a little red dot over in my main method. So drop in the red dot in your main method, because a few of you are still not clear on this one, right? So the visualizers, everyone's eyes up here for a second. To use the visualizer, just click on over here, put 1 red dot in. If you put multiple in, it gets a little confused. And then I can either just touch the bug, or I can right-click on the run arrow in main and debug SList. And then I get my visualizer, and I can step through this thing. And we can see, what did I just say you have to do? Where? In main?
Yeah.
Like, not at main line, but the next one down?
Yeah.
Really? Okay, let's look at it in a second. Okay. Okay, so we've got first, it points at item, it's 2 and null. We add. Oh, this is interesting. That's essentially what I wanted it to do. If I think about adding first, right, I'm adding these things backwards, right?
Yeah.
So I wanted it, like in my head, it was going to come out 2, 3, 5, 8. It came out the other way around because I'm adding the first thing. I'm adding something before each of the other nodes. To the beginning. Right? That's what add first.
I think you want to do it like this way, you add last.
Well, we haven't theoretically implemented that yet. But yes, we would do that. If we wanted to add to the end of the list, we're going to add last. And that's why, right, we could see potentially why we'd want to have both those methods, right, to be able to add first and add last. It's going to be helpful. But this appears to be doing what I want it to do. And then when I call get first, what I'm going to do, because if I just click over this, it's not going to actually do anything. So I can click into the little down arrow, and it's going to say, hey, return first.item. And then I can do that, and see it just went away. But it is first is pointing at the right place, and we're good to go. Okay? And I, of course, also could do, you want me to teach you the other quick shortcut? Yeah. You guys are advanced enough, right? So I can simply do this, SOUT, enter, and that gives me my system.print.outline. Isn't that nice? SOUT, lowercase. If you put an uppercase, it's going to give you imports. It's going to screw you up, but not badly. But it just gives you an import and tries to do something else. But a lowercase SOUT gives you the print line. And then I run this. Yeah, using a real IDE, like you'll see where using a real IDE makes your life, like it makes your programming much faster. Right? Yeah, just SOUT, main, bam, done. Okay, so that's those two. Then we had to, whoops, I don't want to give you that away. We already had get first, right? Well, we just did that. So now we have to do add last and size, a size method. How many of you got the add last to work?
Not sure.
So test it now. So you should be able to go into your main, down here, list.addLast. Whoops. And I'll add, this should be, I'm going to put on 1 because I was going backwards. I'm going to do that. Now I still don't particularly have an effective way to print this thing. So we need to figure out a good print statement on this thing too. So I'll use the visualizer and I can just step through. And so when I call add last, right, it should get tacked on to the 2 item there at the end. Oops.
Wouldn't it be helpful for me to get last one too?
Huh.
Wait, what happened to the?
Yeah, what happened to the rest of the list? Now that's interesting. And when we print get first, let's go. What you can do is you can go to console and see what it prints. It prints 2. All right. So we have a problem, right? It added to the last, but what happened?
Oh, because last is not updated.
So right, everyone pay attention. 2, 3, right? I'm adding to the first. I add first. This is all working fine. I add last, so 1 should get tacked on to 2. And it does. No, it adds behind 2, but I just lost the whole first part of my list.
Does it have to do something with doing get first?
I don't know.
First is not updated, right?
Well, first ends up here, right? So let's think about the way you wrote this. So first of all, what issues do we have? If we think about how we want to, let me rebuild the sucker just the way it was, because I think this might be helpful, like actually to have on screen. Okay, we're here. We go to add last, right? So someone who didn't get this to work properly. Don't you get this to work?
At last.
Yeah.
I think so.
Think so? No? No? Not sure. Yeah, okay. Okay. So where do I want it to go?
Just like,
So I want it to go down here, right? I want this to go here and point to 1. No. A new int node here. Okay. So what's my thought on getting there?
I use that to while.
Okay. Hang on to that for 1 second, honey. What?
Can you see what add last method?
That's what we're adding last. That's what we're doing.
Oh.
This is our add last.
Okay, we're doing this now.
We're doing this now.
Okay.
Yep. So how do I add last? Did you get add last to work or not?
Not sure, but like I just was wondering like how's your method looking like?
Yeah, no, I'm not going to show you what my method looks like. The point is for you to figure out how to get this method to work.
I had a while.
Okay, so are we in agreement that a while loop probably makes sense?
Yeah.
And what's the while loop going to say here?
Like while current, I use like current as a pointer to like first. I use like if current dot next or something.
Okay, so are we okay if I come
Yeah,
back here?
I did that.
Okay, so we're going to have something like while you're saying current. So what's Gordon? What did you use? Because I know what you used. I think. What was in your while loop?
First dot next.
Well, first dot next.
No.
Well, first dot next, because this is might be what is not null. Then what do I want to do? Someone from that didn't get it, tell me what I want to do. So what I'm saying is that first. Go ahead.
First is equal to first dot next.
Yeah. Well, first dot next is not null. So first, this is first. Dot next is not null, and I'm just going to say first equals this. So I'm just chaining myself down to the point where first dot next is null, which is the last node. Give me a thumbs up, thumbs down on that piece.
I use items on this.
Now you can't use item in here.
What the next is it goes red though.
Well, because item, there is no item dot next.
Oh yeah.
Right? Make sure that your variables are correct now. Make sure that you have a first that's an int node,
Yeah.
item's an int, next is an int node. Okay. So while first dot next does not equal null, first equals first dot next, I get to here, and then what do I have to do?
the next.
How do I create the next thing?
First dot next equals new int node.
Let's create a new int node. First dot next equals a new int node, x comma null. And I'm done.
Yeah.
Yeah, we have a little bit of a problem, right?
Yeah.
Gordon and I have a little bit of a problem here. Are we comfortable, Mary, Sienna, Ethan, are we comfortable with that structure? Mary, go ahead. Well, what do you mean first dot item? No. I see what you're saying, but where are we putting that?
Like, once you get to that.
Okay, so we're down here. So we're at first. Okay, you could do that if what? Theoretically, we could do what you're asking, so I think I see what you're doing. But what was your while statement? Okay, but what happens is then first is pointing here, and then you just set first dot item equal to 1, so you overrode this one. Could we make what you're saying work? How? Think about it. Or my while statement could be what? While first doesn't equal null. Because then first would be pointing at this, but the problem is,
Oh, right.
right?
Yeah.
I sort of end up, I could say, well, first isn't null, make first equal to first dot next. But of course, if this is pointing to a null, there's nothing there, so it's probably going to break at that point, right? So that's good thinking in terms of doing that, but I can't override just first dot item, right? Because remember, the null pointer is not pointing at an int node. It's null. So the while first dot next does not equal null works, except for this problem. So what happens is, if we do this first, remember, what we're doing is we just said that first, we iterate down here, we get first down here, right? And then, so first equals first dot next. So we've got first down here, and then we just say first dot next. This pointer is a new int node, just a shorthand, x comma null, right? But when we click that next button, where is first pointing now? At that last node that I accessed. It just cut off all this. Remember, because I can't backtrack my next pointers.
Oh, right.
So by using first to iterate through, I lose my list. Right? You got it. So remember, I always need something pointing at an int list or an SLList or whatever. If it's a linked list, I always need something pointing at the first node of what I want to return. Okay? So, Sienna, what could I do here?
Oh, so I'm just like writing this down.
Yep.
Node temp equals first, like above the while loop.
Sure. And this is the code I had. So back to Ethan's question. I had, well, first dot next does not equal null. First equals first dot next. That iterates me through to the last node. First dot next equals new int node x dot null. And again, that added to the last, but we lost the first part of the list. So all I need to do is make sure that I leave first pointing where it was, and then simply add in some sort of pointer node. So again, see one more time with what you had.
Int node temp equals first.
Sure, int node temp equals first, and then while, just change everything to temp. While temp.next does not equal null, temp equals temp.next, temp.next equals new int node. And let's debug that and see if that's working.
Same thing as what was before, though.
It was, but now think about what happens to my first pointer.
Oh, it stays.
It stays.
Yeah.
Okay, so now I've added 8. Now I go into add last, and what should happen again is I add last, but my first pointer is still pointing at the first node
Oh, give another pointer.
because I've used a different pointer to point at that. Now I can step in and see this in action, which is helpful. So int node temp, right? So I have the, come on. I don't know why. Does everyone else's debugger doing that? It sort of glitches, and then I come down here. So I put temp at this thing, and then I use that temp pointer to iterate through. Boom. The temp pointer is going to go all the way. See, it does that until I come down here. So the temp pointer is going to go down until it's pointing to the last item. Now temp.next is null. Temp.next equals new int node. Boom, there I've added it on the end. And now I've added that thing without destroying the first part of the list. And this is where all those pointers and adding extra pointers to things, like, oh, that's why we have to do that, because otherwise I'm going to lose my whole data structure. Is that starting to sort of coalesce and making sense? Yeah, Mary.
How is it like, because you're just dealing in temp, how does that add to like the original?
Because remember that the temp pointer is a pointer to the original, right? So when I come here, and the way to do this in the visualizer, again, is when you get to add last, step into it, use the little down arrow. If I step over, it's just going to add the node, and I'm not going to know what happened underneath the hood. So I use this little down arrow, and this is where I'm going to be able to see, okay, temp points here, but it's pointing at the same thing as first. I'm pointing at the exact same list, right? And so now I iterate through with temp until temp's pointing where I want it to. Now temp.next is null. Temp.next equals new int node. So I'm now connecting that last node to this here node, right? But that is, first is still pointing at this thing, right? Because if I use first, first just ends up pointing here, and I've lost all of this material. Yay! I love that moment. That's my favorite moment. Okay, so now when I do this, my temp node points here. Temp.next equals new int node. It attached it to the original list, right? And now first is still pointing at the thing I want to keep. Because anytime this pointer has to be pointing at this first thing, or I lose it. Thumbs up, thumbs down, sideways. Okay, now we get a little bit of difficulty.
Wait, so it's just int node temp equals aside to first, right?
Yep. Yeah, so you're just going to create some int node that's a pointer to first. Right? And then you use that temporary pointer to iterate through and do all your work. Okay? Whew. Okay. How do we do then with size? A size method. Now there's a couple different ways to get size, but we want to try a size method first. So here we go. Public int size. What did we do here? Yes, you want to do recursive. But to do recursive, how would we do it recursively? It's an awesome question. Okay, you're on the right track, though. You do want to do it recursively. Here, I'm going to come over here for a minute. I'll do it with you. So I just want to make sure we're all on the same page. Oh, no, I don't want to use that.
Wait, where's that lecture?
This lecture?
Like, how do you find that?
Yeah, you don't. I can give it to you, but you don't have it yet. I'm not going to give it to you until after we're done talking about it.
Okay.
Otherwise, you've got all the code for it.
Oh.
That sort of defeats the purpose.
Yeah, it does.
Oh, we're not even there yet. Okay, so actually I'm going to freeze that back because we're not there. We're not there. Size, efficiency, adding. Okay, there we go. Okay, so how do we think we might want to add size? Recursively.
I like copied it over from the last one, but like it's having some things at the end. Wouldn't it be if first dot next equals null as a base case?
Yeah.
Return one.
Okay.
And then after that, return one plus first dot next dot size parentheses, but then at the size parentheses is where it's like not liking it.
Yeah, it kind of breaks at that point.
It's something to do with like.
Because what do you want with that side? You want something there, right? What do you want? Think about what you want to add to that. Can you share your screen for a second, actually? Do you mind?
You just want to add one.
One to what, though?
Incorporate this inside the int node class?
No. No, you want, so that int node class stays that simple little, we're not going to change that int node class at all. Now that we've got it, We're not going to touch that thing. Okay?
Isn't iteratively much easier?
Is it much easier?
I mean, I did it iteratively,
And it works?
yeah, it's really
I'm
simple.
connected here, but
I know, because I need to do this.
You just need like a counter.
Yeah, I did the same thing.
All right, I want to see. Let's look at it in a second. Okay, so let's look at, size. If first dot next equals null, return 1. Return 1 plus first dot next dot size. But what's the problem with this? How many is it going to capture?
Oh, 1.
1. You're never iterating through the whole thing.
Wait, what?
What? Okay, let's look for a second. Think about it. We've got
The length of each node is 1.
yeah.
Yeah.
So if you've got this, the recursive stack, I can get rid of this stuff, right?
It should be within the.
Well, no, this is really important to see our structure that we're going to use. Let's blow that up, because I can't even figure it out. So it does make sense. What?
my little question is
Oh, wait, we'll go back to your pets in the corner. Yes, there's. You can share how you got those in a minute. Okay, so size. If first dot next equals null, return 1. So we're going to go here. Is first dot next equal to null? Okay. So that's not the case. So I'm going to return 1 plus first dot next dot size. Okay. Well, when I come here, so think about where's first. This is the trick with this one. Where's first pointing? When we start, where's first pointing?
1. First one.
First is pointing. My pointer's there.
Yeah.
So okay, let's go through the code again. Is first dot next equal to null?
No.
Okay. Return 1 plus first dot next dot size. First dot next dot size. Well, I come back up. I'm going to come up back up. Is first dot next equal to null?
Oh, no.
It's an infinite loop. I'm never iterating first. What you want to be doing is, this works if I could iterate first down the line till first dot next was null.
Did we get a temporary?
How?
Oh, yeah.
How? You could. You could, but I can teach you a different structure that we're going to use. We're going to use a lot. We're going to do something slightly different. What theoretically would make our size method much easier? Well, what if I had it such that I was passing in a node to size? And then I could iterate, I could use that node to iterate through to the end and recursively call it. Ready for this?
Wait.
So what I'm saying here is that you're not iterating first through. Yes? That's the problem with the structure you have. Okay? But what if size passed in a node and then used that node and just did node.next? Yeah, see, this is where this is a structure, and we've talked about it a couple times now, where we're going to use recursion. Well, no, you can't, because so theoretically, could I create a size method, right? I could create this size method that took in an int node x. But every time I call size, do I want to think about what node I'm passing in, or do I want to just be able to call size on the list? I want to be able to call size. I don't want to pass this in. So this is going to be a private helper method. So watch this. Ready? I'm going to do it on your. I'm going to see if I can do this. I'm going to channel myself through you.
Like you have a private and a public.
You got it. So what we're going to have is we're going to have public int size, right? Don't. We're going to change it to this way.
Yeah.
We're going to do this. We're going to say above that, yeah, you're going to have public, anywhere in there, public int size.
And I'll just call the private method.
You got it. Public int size. No, not size one, just size, parentheses. You're going to recopy this method header. It's not going to like it, but that's okay. And you're just going to return size, but you're going to pass in a parameter. You're going to pass in int node. You're actually going to pass in, no, because you don't want to pass in a parameter. You want to pass in just an argument. Pass in node. Just call it node. Okay? Okay, that's it. Now here, this is going to be private. We're going to have a private helper method. And you should put a comment in here that says this is your private helper method. No one's ever going to see this private helper method. Private int size, and you're going to pass in an int node node. It's okay. Private int size, and here you're going to pass in an int node.
Why is passing in an int node?
You'll see. Okay? So now, if I wish I could get better clarity on this. This kind of sucks, doesn't it? Okay, so we have public int size, return size node. Okay. Private int size. No, just leave everything for a second. Int node x. Because you're going to see you have the right code. We just need to change a couple things. If what here now? Not first. N.next equals null, return 1. Return 1 plus, get rid of all that. We're just going to call, now we can just call size on, yeah. And we're done. That's it. Now try it. Try calling, you can just run it. You can run it or you can debug it, either way. No. Oh, first. Pass in first. We just want the first node. Sorry. There you go. And you might want to open that up. Here, scroll. Oh, it's because here. Grab your bar and open it up so everyone can see it, just so we can get a better visualization. Okay, so there we are. Oh, and if you go to console, let's just check it. Before you do anything else, just click console because it's there. Oh, why? Can you see the number there? Because I made it. There. So Y65, print out, oh, list got first, right? So what size should be 1, 2, actually we started with a number, so 1, 2, 3, 4, 5, 6, and we printed out 6. So our size method is working, at least as we can see right now. So go back up to your methods for a second. So this, just your size method, sorry. Go down a little bit. Okay, so this structure, we're going to use this really, really frequently, where we have a method call, and what we do is we return a private helper method with some parameters passed in, okay? Because it makes recursion much, much easier, because then I just have this, or even iteration it makes much easier, because then I have this private int size, no one will ever see this, I pass in a node, and then I can say if n.node, and let's look at this over here just for a second. So now, for my size, I'm saying size of some int node, n, right? It's small again. And so then I say, wait, where's our size again? Go back up. No, that's okay. Stop at size for a minute. Okay. I'm saying int node n. So if n.next, and remember, what am I passing in when I actually call it in the basic size method? What did I pass into size? If I scroll up a little bit, what did I pass into size? right there. First, I'm passing in first. So what is n a pointer to? First. Right, so n points at first because I passed in first in the size method. And then when I go to my private helper method, if n.next equals null, so does n.next equal null? No. Return 1. Okay, so no, we're not there. Return 1 plus size of n.next. So n is going to iterate through here, okay, unlike our first until we get to the end, and then you can get the full recursive stack. Okay? And then it just unpacks, it just adds all the ones from the recursive stack. Okay, because when I get to n.next equal to null, this n.next equals null, I return 1, and then I just come back up the recursive stack for every return that's n plus. Or, sorry, 1 plus size of n.next.
Can you just replace size and next with 1?
At the bottom, the recursive call?
Yeah.
It would just
end it.
You mean of 1 plus size of 1?
Yeah.
No. It would just end after the first recursive call. Yeah.
I don't know why, but I can looking at this, I can understand how this works.
Yep.
But when I'm going to write the code, I can do it errorly, but recursively, I just can't think through writing the code. Is there a trick to being able to think through it?
Practice drawing it out and just practice.
You just want to draw it out completely. Okay.
Yeah.
And is it just complete trial and error kind of thing?
No, I'll give you some of the leak code recursive problems will help you sort of think through the recursion piece of it.
I just can't write the
Recursion is really hard to wrap your head around. I'll be honest that here, let's do this. Will you go ahead and run your debugger again? And I'll show you how the thing that I find most easier is drawing it out, like you've been saying, but then you go to visualizer. Okay, so step over. We don't want to add, we want to do all step over, go all the way down to just size. And now step into. So if you step into the size and just click on size, we don't want to step into print line. It will let you do that. So it's going to say, so now let's go ahead and step into, you got to step, into each one of these. So it's going to say return if n.next equals null. So here's my pointer n, and this is where these visualizers are super helpful. So this is n pointing here. It's not null. So go ahead and click, click. Return 1 plus size n.next. Click again. Right? So now I've got this is my recursive stack. So now n's pointing at this thing. It's n.next. n.next equals null. Nope. Click. Return 1 plus. Oh, now n's pointing at this thing. Go ahead. Still not null. Now it's going to point at this thing. Okay? So now n, we've got we've got this whole recursive stack, all these n's pointing at each one. Go ahead and hit it again. Still not. We're going to return 1. Now n.next is null. Okay, keep clicking into. Now I return 1. So my return here is going to be 1. Keep going. Right, so I've got 1. Now it's keeping track of it under the hoods here, so I can't really see size just yet. And it's just going to keep returning 1 with each recursive stack.
Yeah.
So it's going to return 1, return 1, return 1. Keep going. And then I'm finally going to return size. And because I went through with each one of those and returned 1, it's going to return 6. I can't see that unless I go over to console. Actually, one more click. And there's my 6.
I think the best way to visualize this is to draw a tree.
You can do that too.
Because
recursive.
yeah, because in that way it's really easy to understand. You won't forget that there's a 1 plus whatever. You're just calling a function within itself. It's really easy. It's really easy to understand the tree.
Yeah.
And a tree is where you have start from the first one and then kind of just build off of it. So you can put the 1 and that sort of thing. I feel like I can the computer science, the problems like this, having you kind of answer to what the like input is, that I feel like I can do with a recursive tree, but just writing it.
Building the code itself is
Just
tricky.
Building the code.
Yep.
Yeah.
Yep. Do you want to share? Why don't you share your iterative version?
It's so much more simpler in my mind. Like, I can't do the recursive one.
Well, so the reason that we're focusing on the recursion is because we're going to use that private recursive, or it's not even a recursive method, a private helper method. We're going to frequently use a private helper method. It doesn't have to be even recursive, but we're just going to use a private helper method to do it. Okay, so x equals 0, well, first does not equal null, x plus plus, first equals first dot next, return x. So do me a favor here. Go ahead and step through it. So go ahead and let's visualize it. If you drop in, let's do it down here just because it's going to make our life easier. Do it in your main method on 45. One more down. There you go. And then debug that. And then step into, step over each one of those things till you get to size. And now step into, and it's going to ask you to step into, click on size. Yep. Okay, so while x equals 0, and just keep stepping through that one. Okay, well, first equals, does not equal null, x plus plus. Go ahead and step through it. And we're literally cutting items off of the front of the list. But now there's a trick to your, actually keep going. Keep going. Cool. All right, now, right here, after list.size, go ahead and print get first again. This is a way to also debug your code. What's going to happen? Oopsie. What happened?
Exception.
What exception?
Cannot read item because this not first.
Yeah, why? Gordon, go back in, re-debug this thing.
Oh, it's because we're cutting each item off.
Because you're taking first, and you're doing that. So what's one solution to this?
Like create a temporary.
Create a temporary pointer. Let's try it and see if it works. Look at that. It gives it to you right there.
Yeah.
All right, now let's run this thing and see if that worked. Yeah, go ahead and debug it that way. So everyone see what happened there?
Yeah, so first doesn't move.
Yeah, because he used first, and when you do that, it's literally getting rid of the whole list.
Right.
Yep. Yeah, of course. Okay, so now this, theoretically, should give it to us. Return x. Go ahead and hit one more down, yep, and then go into the console. Click on console right here. It should have an output of 5. 1, 2, 3, 4, 5. Yep. So iteration in this case is probably easier, but the recursive method just helps us see that private recursive method. Did everyone get a size method of some way, shape, or form? Yeah, yes, you go. Okay. Good? No? Awesome. What's the easier way to do size? Say it again. We have a built-in method.
Well, we're creating a.
Yeah. What do you mean?
Does that work for? No, it doesn't work for consoles.
What? No, talk. What were you saying, Gordon? What's an easier way to do size?
What do you mean easier? Like iteration or recursion?
No, like, so think about this. With our current methods that we just did, either the iterative version or the recursive version, if I've got a list of 1,000 items, how long is it going to take me to return size every time I call size? How many steps is that method going to have to go through? N, 1,000 steps. Every time I call size, it's going to have to go through every single node. Count them up. If there's 1 million of those things, it's going to be a really long time. Right? What's faster? It's a better way to keep track of size. And this one you do know on a rather simple level if you think hard about it from the AP class.
Every time, like, add first, you have like a big.
What do you mean? Yes. Say that loud. What do you mean?
The add first method, I just increment like a value.
Add first. So, yeah, right? Do I want it to be, I mean, so private, what? Int size. And then when I create the list, what do I have to do?
I mean, what?
Size plus plus. When I add something to the list, size plus
So
plus.
shouldn't the first size plus plus be size equal to 1?
Well, when I do this declaration right here, what happens to size? It's a default. Because it's an instant variable, it defaults to 0. So this does work. And then get first, I don't do anything. Add last. Size plus plus. And then I can get rid of that beautiful recursive method, iterative method that you spent all that time on. And what am I going to do here?
Return size.
Return size. I've just incorporated all that work of calling size into each iteration of creating something. You just missed the whole thing, man.
Really?
Yeah.
I'll come in during your help, maybe.
No. So, Alex, the question is, what's easier than having a method that calls size?
What's easier than having a method called size?
If I have a list of 1,000 items, and the way we were building it, and I call size, how many steps does that method have to go through every time I call size?
Like the amount of items there are.
N items. What's the easier way of keeping track of size?
Going then.
Nope.
It's literally right there.
Oh, yeah.
Just having a size variable and incrementing the size variable.
Oh, yeah.
Yeah? That saves us a lot of time and energy. Okay? And so the point of the exercise is specifically to see that recursive helper method.
What if you have two different S-lists, though? Like if you create two different S-lists, one, like, don't you have to...
Size is an instance variable.
It's a static.
It's not static.
Oh, yeah.
It has to be an instance variable. So it's not static because I do want it to be able to do every S list. Right? So when I come down here, instead of I have to call, still have to call
You don't have to reset size.
list.size.
No, there's two lists.
Right, now it's a method, and if I run that, it should print out whatever I have here. 5.
What if it's a public?
What if it's what?
It's a public variable. You can just do it. You can get it right.
We don't want any public instance variables. Don't want to do that.
You create...
I don't want people to go in and screw around with the size of my lists. I want them to be able to call the size method, and it returns the size of my list. Because otherwise, you could have a list of 1,000,000 things, and I could sneak in and say, nope, size equals 4.
You can get it right.
That's what size is here. It's a getter method, because I'm just returning size. But instead of saying get size, I'm just saying size. You could call it get size.
But now you're just running like a whole recursive thing, right?
What?
With the size.
No.
Have you changed it?
No.
Yeah, you changed it.
I'm not, there's no recursive, there's no iterative. It's just every time I create a node, I'm adding to the size, and it's just keeping track of it internally. Yes, Sienna?
Side thing is, or just like aside from all this, will we go over a print method?
How to print this thing?
Yeah, because I'm trying right now, and I tried it with a public or with a private helper thing. Because at first it like small didn't work.
Okay,
But I'm just asking if we can go over that.
let's do it. So where would be the first place to look?
I just copied it over.
And what did that look like? That's great.
Well,
What, I put it in homework, didn't I?
Yeah, I changed it a lot, but it was like.
So let's go back. Okay, we did add last and size, right? We're comfortable with all that?
So we do size plus plus to add last and add first.
Yes, and the constructor.
And so we do, I created a thing where public and size return size.
Public int size return size, correct.
And then should I delete my old method where I did it iteratively?
Yes. Sorry, but we don't need it anymore.
Sorry.
All right,
Yeah.
so print list. Ready? We're going to print list. System.out.print first plus space if next dot. So I have to think about this now. If next does not equal null, next dot print list. What do I have to change here to get this thing to theoretically work? I don't have next. I mean, I have next, but how do I have to call next in my print list? If first,
Well, not first, right?
well, do I have to start it first?
Yeah.
I do, but what again, we should be learning some lessons here.
Well, it's int node, and then you have to create like a temporary thing, because like it'll lose it, right?
Well, yeah, if we think about first here, what do we actually want? I don't want to print first again. If I think, dot item. So I'm going to print first dot item. If first does not x equals null, but I have an issue here.
It's not first dot next time.
No, you have.
Is it though?
Okay, so you have to do print list int node n, or like whatever variable, and then do n dot item, or just like get rid of first, like create a thing.
So I have to create another pointer.
Yeah.
Is that what you mean?
Yeah.
Yeah, why?
Because you're gonna like lose it as you go.
We're going to do the exact same thing, iterating through first. I'm going to lose my list.
And like,
So again, we'll do int. Whoops. We'll do int node temp. I like that thing equals first. Print out temp dot item, temp dot next, temp dot next dot print list. Doesn't like that. Cannot resolve print list in int node.
or how about you put it just in the header?
What do you mean? Put in.
Like int node n.
But I want to just be able to call print list. Again, I don't want to pass this in, so what can I do?
Well, create a helper, like, and that's what I'm trying to do. But then I'm like, wait, do I have to make it static?
All right, let's try it. So we're going to do this. Everyone should try and make this happen. Everyone try and make this happen. This is your coding assignment here. This is what we'll do for the next few minutes. So try to take this print list. Right now it doesn't like this recursive call. Cannot resolve method print list. Create method print list in int node in SLList. Wait, hang on for a second. Why? Oh, okay. So this will actually, I take it back. Because here, do we want to make this? I got to think about this for a second. This is theoretically telling us that this should be inside of our int node. So can we think of a way to do print list here? We could try the recursive method, but what this is specifically saying is that this is an int node method. Shouldn't it be in int node? Let me get rid of that because we don't need that anymore. So I could try and drop this into int node, but is there another way to do?
I'm like trying to make it public, or like with a private helper method, and then it was being weird, so I changed it to static.
So could this one be static? Or not? What do we think?
No,
Why not?
because each list is different.
Yeah, can't make it static because we want to be able to do it differently. So I wasn't planning on adding a print list into this thing because honestly, it does become a little bit of a challenge. But we can try. Is there a way to print out a list?
You can just have a variable that's a empty string and just like concatenate each iteration.
Okay.
And then just print out the string at the end.
What happens if you like have a or like have another method that changes stuff in this though?
What do you mean?
Like let's say if they, I mean, or I guess these type of classes aren't really, you don't really like mess in the middle of them, but like if were to mess in the middle of it, would it mess with, or like if you were to replace something with something else, would it mess with what he's saying? Even though you usually don't do that.
I'm sorry. You lost me, I'll be honest.
Never mind.
So why is it, first of all, why is it telling us that we don't have a print list method? Temp.next.printlist. So I have a couple of different choices here, right? Rename reference. No, don't want to do that. So let's see if I don't know that I want to spend the time on this, but we'll spend a minute on it. Public void print list return print list first. Print list, we're going to make this private. With the private helper method? Yeah. Awesome. Int node n, print out. Now here we don't even need the temp, right? You just did away with the temp variable, right? Or did you use the temp variable?
Yeah, I didn't create anything new. I just like added them as a header.
Yeah. Oh, now I'm still getting that error. Oh, sorry, that's why. Sorry, hang on. And next. Yeah, I do. Because I'm a little confused on why it's giving me the error it's giving me.
I don't know how that has worked, but...
Well, if it works, hey, all right, let's take a look. I'm getting an odd error on mine. So, I need to do this again. Search source and unfreeze. Is that you or me? That's you. Okay. Print list first. Yep. Print list. If n.next does not equal null, print list n.next. Oh, that's why. Ha! I see what I was doing wrong. Okay. No, just go ahead and do it and see if it works.
It did. It's down here.
Okay, there you go. And honestly, what I would probably do is, I don't like visualization this way, so I do print instead of print list, println. So in line 28, just get rid of the ln. Get them on the same line, so just do that. Yep. Nope, get rid of ln. So on line 28, get rid of ln, so just print and run that. And what that will do is put us on one line. And put a space in the space. So where it says n plus item plus space, now write one more time. There you go. And that's to me, that's just a nicer visualization of a list. Right? 5, 4, 3, 2, 1, 6. Yep. And this is sorry, hang on. This is a perfect example of why a recursive helper method helps.
Yeah. I was like, because I was trying that earlier before class.
Yep.
And then you went over the helper methods, so while you're talking, I was trying to figure it out.
Yep.
I did it iteratively.
Cool. That works too.
Yeah.
You want to share that? So now we can come in here and we can simply, we should be able to, of course we don't have to do that. We can just say list.printlist. No, you guys got to figure it out.
No, I cannot run the method.
Incompatible types, expected return value. Return, oh, no, not return. Okay, so here's an iterative version of it. So temp equals first, and so this is a similar thing to what Gordon did with the last one, right? We've got a space, well temp does not equal null, a plus equals temp.item, temp equals temp.next, and print out a. Oh, you did? Yeah, okay, cool. Run it, and so you've got the same thing. I just again put a space in with a, and that should, yeah, plus space. Make it a space. Yeah, there you go.
What's
Yep.
the runtime or like between the two?
Oh,
Between like a helper.
that's a great question. My answer is probably they're going to be pretty darn similar. I don't think we're worried about runtimes on this. Because theoretically, what's the runtime on any print, anything like this for printing? And it's just going to be a linear time. You have to go through every item to print it, right? You'd have to work, well, no, you probably wouldn't have to work that hard, but you'd probably have to work fairly hard to make it quicker, or just slower than that. And is there any way to make it faster than going through every item to print them? I don't think so. Not that I can think of. So I think that they're going to be pretty similar. It's just the structure of the recursive call is going to be useful to us. So that's why I think focusing on, not the recursive call, the private helper method, regardless of whether it's recursive or not. The private helper method is going to be helpful to us. Okay, what time do we go till?
150.
How do I keep just losing entire class periods here? 1:50. We have 5 minutes. All right, you got 4 minutes. Your job, you can start it right now, is to add an empty constructor. Should be pretty easy. Okay, so add an empty constructor, and then your homework is to figure out why the empty constructor, what's a potential problem with your empty constructor with what we have. Okay, that's the size method, caching, empty list. So an empty list, that's what you're trying to add. And why would we want to try to add an empty list? So my empty constructor is going to be something like, I'll come up here where my public in. I typically put my empty constructors in first.
Your screen is
Not showing. So I'm going to do, public S list that. No, so this is, we're not putting anything in IntNode. That's the goal, is to not add anything in IntNode. So this is a constructor for SList that takes no parameters.
Do we run it?
Yep, try it out. I mean, it should be pretty straightforward to make it, but then you're going to see potentially why it breaks. Because you really only need 2 lines of code for this thing. What 2 things do I need to account for? And actually, if I go like this, I only need to account for 2 things. What do I need to account for? First and size. So I'm going to put people on the spot. Mary, what should first be? Think about what's the simpler way of doing that. Equals null. That's it. Because it's not a new int node right now. It's just null, right? I don't want to create the structure even. And then, of course, Donald, what size? Yeah, it's just empty, right? It's 0. I don't have to put in 0, right? But I should account for size. Yeah. What do you got? Because I'm not adding a node yet. This is just an empty list. Now, tell me why it breaks. What breaks this thing? This does not actually work. Tell me why it doesn't work, or what doesn't work with it. You're probably not going to be able to figure it out by looking at it. You're going to have to play around with it a little bit. Mm-hmm. Ready? I'm going to run this. That worked. I created an empty list. 3, 5, 8, 1. Let's come down here. Oh, but I did it add, okay, so I did add first, so it should be 8, 5, 3, 1, and then I printed out get first. Wait, why did get first not give me a number? And then size, 1, 2, 3, 4, that's correct. Why is get first not, oh, get first gives me 8. It's, for some reason, I need to, let me just do this.
Isn't size 5?
No, I added 4 things to it.
So then you got
When I create a list, there's no size. 1, 2, 3, 4 things.
Wait, can you go find out?
I just want to make sure we're clear on this one first. Alex, you understand why it's not 5?
Yeah.
Because this is not, when I create an empty list, there's no structure there. That's why it's null. Where am I going? So something breaks this. See if you can figure out what breaks it. That's your homework. And I am going to give you a recursive leak code to play around with recursion a little bit more. Okay? Have an awesome rest of your day. Yeah. And I'm going to give you, actually, one other thing I'm going to give you for homework is a CIQ. I want to check in with how people are feeling about the class. I should have done that earlier. Here's what? You gotta figure out where's that degree from? Homework. Have a great rest of your day.
Okay. Thank you.
All right, I'll see you later. Have a good rest of the day. Woo! Challenge the brain. Time for you can just sit right there, can't you? This is the only time we have it back to back.
No, we have other times back to back. I think it's the other order first.
Oh, okay.
Oh,
right.
Is ethics really interesting?
Yeah.
What is it like? What do you want? Just like ethics? AI.
We haven't talked at all about. Well, we sort of talked about AI, I guess, didn't we? I'm going to reorganize the room. I have an idea for a different room.
Ethics is super broad. Like as a whole, it's like hard to talk about.
Do you like follow like a college curriculum or like?
Oh, just explore the basic ethics.
For right now, we're working on.
Wait, do you want to go?
We're working on getting that to be different.
Second semester?
Really?
This year? When I'm still here?